Greetings. Why am I so honored to be talking with you about teaching physical and cultural geography with GIS? Joseph Kursky here. Thanks for joining me. The bulk of my teaching and research career has been focused on the implementation and effectiveness of GIS in teaching and learning. As an example, my colleagues and I just finished this book on teaching mathematics using interactive mapping, with 65 new activities, not just for math teachers and instructors, but also for geography, economics, and other subject instructors. Shown here is one of my research articles on this important topic. Why should we care about teaching these topics with GIS? Well, our world is being challenged by human activities, as you can see here, and we could have a whole chat about this if time permits. Sustainability is possible, but we need some serious adjustments in society. I believe education plays a key role. The geographic approach is a way of thinking and problem solving, and not just for geography, but multiple disciplines. Because GIS enables the geographic approach, I see it as something that all faculty members should use. Not in the exact same way or with the same goals as how the GI science faculty use GIS, but to teach about biomes, population change, energy, water, natural resources, natural hazards, human health and behavior, equity, and other core topics in geography and beyond. Because of the advent of GIS to a cloud-based platform, GIS has changed. Central to this discussion is that these changes make teaching with GIS achievable and exciting. Modern GIS web tools make these approaches extremely intuitive. Wait until the AI tools make full inroads to GIS. The dependence on the interface will further be reduced. But this tool is still the most important, your brain. And the role of instructors still matters. You, as instructors, are framing the inquiry. You can't and shouldn't learn all the GIS tools to teach with. And these are just the ArcGIS tools from Esri. GIS as a platform means that you can choose pieces of it to use rather than the old days of everyone having to use and learn the same thing. This remains a challenge. What should I use? How can I start? This ebook I wrote includes 15 reasons to embrace GIS as a teaching tool, reasons that are central to why you and I became educators in the first place. Inquiry, problem solving, empowering students to be change agents, holistic and critical thinking, enabling students to discover their interests, helping students to care, and so on. Discuss these 5 forces: geo-awareness, geo-enablement, geotechnologies in the cloud, crowdsourcing, and storytelling with maps, with students to explain that GIS tools are all around them, some of which they use daily. If students acquire these abilities, they truly have superpowers. My list of 10 things evolves, and we could have a discussion about them, but they include mapping fundamentals, location coordinates, measurement, map types, geodesy. Number 2, creating maps from tables, sketching, geotagged information, and unstructured data. Number 3, classify, symbolize, filter geodata. Number 4, write code, even starting with few lines of arcade expressions. Number 5, collect and map field data. 6, share and serve geodata. Decide when to share, when not to share. Number 7, build apps, story maps, dashboards, instant apps. Number 8, conduct spatial analysis. 9, critically evaluate and use spatial data. Number 10, understand the ethics of mapping. My most often used and recommended 15 tools are here. You will see that half of them are part of the ArcGIS system. ArcGIS Online Map Viewer, ArcGIS Scene Viewer, ArcGIS Living Atlas Apps, the Wayback Imagery, the Land Cover Change, Water Balance, Wildfire Aware, Air Quality Aware, etc. Number 4, ArcGIS Living Atlas Data. Number 5, Gapminder. 6, World Mapper and Bouncy Maps for cartograms. 7, Axis Maps. 8, Story Maps. 9, ArcGIS Survey 123. 10, Visualizations, ArcGIS Dashboards, and the Tableau Gallery. Number 11, NASA Worldview. 12, EPA Enviro Atlas. 13, Google Maps and Google Earth. 14, Earth Null School. 15, the Esri Nat Geo Mapmaker. I use these not because they are the flashiest, but because, number one, they adhere to and support course and learning objectives across multiple disciplines. Number two, they will be there in the future. Number three, they offer analytical capabilities. How can we future-proof the curriculum? Well, we can't entirely with the rapid changes in education, society, and technology. But number one, teach the fundamentals and not the interface. Number two, keep your GIS use anchored to your program goals. Number three, make it holistic, multi-scale, visionary. Please make it interesting. See more in my 10 strategies. You might need to give up some of your long tried and true lessons, as I have. That can be painful. And please don't overscript these lessons. Include ethics, communication, and cartography throughout your courses, not relegating this to week 15. Rely less on traditional exams and papers, and make assessments increasingly web mapping applications, audio-video, and portfolio-based, as my colleague James Ratlingleaf and I did here, with our Lakota language story map. Fieldwork can be revived as exciting and doable, enabled by GIS tools such as the crowdsourcing available in ArcGIS Survey 123. My 9 most used activities include creating bivariate maps and scatter plots showing 2 unrelated variables and then 2 related variables. Analyze change over space and time with the ArcGIS Living Atlas Wayback Imagery and Landsat Explorer. Analyze real-time data, stream gauging stations, weather, wildfires, and more. Collect, map, analyze, and communicate field data, trees, walkability, water quality, historic homes, dangerous intersections. 5. Measure perimeter, area, slope, weight, and volume of hills and plateaus. Examine spatio-temporal patterns of 72 years of tornadoes, 150 years of hurricanes, and other rich data sets. Number 7. Examine proximity of population, plate boundaries, earthquakes, and volcanoes. 8. Analyze change over space and time of zebra mussels, 1988 to 2020. Number 9. Teach current events using a GeoNews format. Here's an example. Let's examine why certain areas are changing rapidly, other areas less so, and why they are changing in terms of land cover. Let's examine world population density with this 3D globe. Is modern GIS web-based tools intuitive? You be the judge. Let's examine litter in a city center and then form a plan to take action. Okay, let's pick a field to map. Paper, okay. Now we've got a graduated symbol map with the amount of paper in each point and pop-ups. We can examine the table of data itself as well. Let's add all of the fields so we get a predominance map showing all the types of litter in an area. Let's adjust that symbology so the symbols are a little bit clearer and larger. Now the type of litter that's predominant shows up in this color. The strength is the darkness of the color. So here I can see at 6th and G that plastic was predominant. There were 14 pieces of plastic that I found there. But one block to the south, glass was predominant, but not much so. 10 out of 20-some points were glass. So we have 2 kinds of data being shown in this map. Let's keep going. How about a pie chart map showing the types of litter in each location? Let's adjust that a bit for a ring chart instead of a pie chart. Let's change the base map so we can look at the features underneath. What's the relationship of these points and the amount and type of litter to touristy areas such as the gas lamp district or this baseball field? Are there recycling bins? Should there be recycling bins? What time of day did I collect the data? What day of the week? What time of year? Is the litter problem mostly from tourists or is it from locals? And if so, how can we raise community awareness? Modern GIS web-based tools are intuitive. Work with your campus admin and facilities to obtain additional support for teaching with GIS. Also, advocate for a geospatial librarian to champion this across departments. Inspire students with future directions that GIS is going, not just looking at how things are, but how they could be in the future. GIS, BIM, CAD, design merging, artificial intelligence, 3D analytics, real-time data feeds, and more. To bring additional students to your program, consider a Digital Earth or a Smart Planet course. Be thoughtful about how we name these courses as well. Let's make them exciting, not GIS intermediate, but Smart Planet, Digital Earth, beautiful maps, etc. Thanks for being with me, and I look forward to discussing the pathway forward with you all.